All right, we're going to walk through a short little taxation practice problem here, showing the equilibrium effects and the welfare effects of an excise tax, in this case imposed with a legal incidence on the supplier of a good. So we'll have a little numerical example and walk through the diagrams as well. So the scenario doesn't really matter for the purposes of how this all shakes out, but a fairly realistic case here. So we're looking at the market for avocados in the US, specifically imported avocados. So the tax that we're imagining being imposed here would actually represent a tariff on imported goods. And we have our initial situation here. So we have price per pound increasing, indicating quantity demanded will be falling, quantity supplied will be rising in the associated columns. Uh, and we're asked to find the initial equilibrium and show it on a diagram. And then the little added question that's going to be important later on in terms of the tax is just simply commenting on the relative elasticities of supply and demand, not doing any calculations here, but just kind of looking at the numbers to get an indication of the relative slopes of the curves. It's going to be important that we diagram it correctly, such that the relative burdens of the tax come out to match the scenario. So the first part, equilibrium, we notice, of course, right away that quantity demanded equals quantity supplied at 100 when the price is equal to 5. So that's our initial equilibrium. And we can go ahead and sketch that out. But before we do, we want to make sure we draw the diagrams correctly. So we notice on that table that every time the price changed by $1, the quantity demanded changed by only 10 units, quantity supplied changed by 20. Again, it's more complicated than this when we actually calculate the elasticities, but certainly what that indicates is that in this region of the demand curve and the supply curve, demand is more inelastic, right? The change in quantity is smaller for the given change in price. So again, that's going to indicate how we will sketch out these curves. So an inelastic demand curve is going to be drawn as a relatively steep downward sloping line, such as this. And then a relatively elastic supply is going to be a flat upward sloping line, such as this. So we have our initial demand curve, our initial supply curve. Supply is going to be moving, so we'll indicate this as S1. And then the equilibrium price, as we saw, was 5. Equilibrium quantity was 100. Check and check. There's our initial situation. So now, starting with that, we imagine a $3 per unit excise tax is being imposed on the sellers of this product, avocados. And again, since this is a tax directly imposed on imports, we would actually indicate this as a tariff. The impact on the diagram and the equilibrium is going to be the same. With that setup, we are asked to show the impact on the table here by filling out that last column, that price plus tax column, which, as we'll see, is going to be the height of the new after-tax supply curve, and then show it on the diagram by shifting the correct curve in the correct direction, and that's going to be shifting the supply curve upwards. So the first part of this, pretty straightforward. We just take the original price in our first column and add 3 to it to get our values in the new column over here. So 3 plus 3, 6, 4 plus 3, 5 plus 3, 6 plus 3, 7 plus 3, 10. That's the kind of math I like. Nice and easy. So now showing it on the diagram, we're going to be taking that original supply curve and just moving it straight upwards by the value of the tax. The $3 moving upwards at every quantity. And remember what this represents, the height of the supply curve is the marginal cost of producing that last unit. And the original supply curve represents the cost in terms of natural resources, labor, capital, etc., the physical production of the product. And then we're adding on top of that the government holding their hand out saying, you got to give me $3 on top of that. So that increase in cost, right, is going to be shown as shifting that supply curve upward. So we get a new after-tax supply curve indicated as ST that is above the original supply curve by the amount of the tax. So that vertical distance is the tax. So make note of this point here, right? The intersection of the new supply curve and the original demand curve, that's going to be the new after-tax equilibrium for the consumer. And we note that it's at a higher price and a lower quantity than the original equilibrium. Our next task is going to be to figure out numerically exactly where that is. Okay, so starting from that same set of information here, we are asked now to find that after-tax equilibrium, the price paid by the consumer, the quantity traded at that equilibrium, and then the second price, the price received by the seller. Remember, these excise taxes, we say, form a wedge between the price that the consumer pays and the price that the seller receives. And in between those is the government taking their share. So we're going to end up with two prices and a new quantity. And we're going to show this on the diagram. So remember, we saw on the diagram that the quantity traded is going to have to be lower than it was at the original equilibrium. So that's always a good place to start. The original quantity was at 100. So let's go back from there and see where we can find that equilibrium. So we notice that on the new supply curve at a quantity of 80, the height of the supply curve is 7. And we notice that on the demand curve, at the quantity demanded of 80, the height of the demand curve, which was the original price column, is 7. That seems like a match, right? So quantity supplied equals quantity demanded. Both are 80 when price is 7 when we compare the new supply curve, which is this combination here, to the original demand curve, which was our original combination QD and price here. So price of 7, quantity of 80, that's going to be at our intersection point here. Okay. Intersection of the new supply curve ST and the demand curve originally. So that's going to be our consumer's price of 7. The quantity is 80. And then that last piece of the puzzle, the amount that the seller gets to keep, the PS, is the amount that the consumer pays minus what the government takes in return. So we had the consumer's price of 7 minus the tax of 3 is going to leave the seller with 4. So PC and QT, that's the intersection point here. And then we go straight down to find our seller's price. And just remember that the vertical distance that we're moving down here from the original supply curve to the, between the original supply curve and the new supply curve, going down from the new to the old, is the amount of the tax, right? So that movement here shows us exactly the operation that we're doing here. The original, or the consumer's price minus the tax. Okay. So that's probably the trickiest part of these problems, is translating the shift on the table to finding the new equilibrium point. But once we find that and we know what it represents, everything else kind of falls out naturally. So once we have those values, we can now do some of those welfare impacts, right? So how much of this tax is being paid by the consumer's burden? How much is being absorbed by the seller, the producer's burden? And then how much money is the government making off of this operation? GR, the government revenue. So as far as calculating the consumer's burden, right, we're basically just asking, well, how much more are they paying for the units that they are buying after the tax? So it's the difference in the price, the new price minus the old price, times the number of units that are consumed after the tax. So the consumers are paying 7 now. They used to pay 5, and they're still buying 80 units. They used to buy 100. That's come down to 80. So they're paying $2 more for each unit times 80 units. So that's $160 in consumer burden. On the producer side, we're asking how much less revenue they're earning because of the tax. So that's going to be the gap between their old revenue per unit, the equilibrium price before the tax, and the new revenue that they earn per unit, PS, the after-tax seller's price. So that's the lost revenue per unit times the number of units that they're still able to sell after the tax. So it's original price of 5 minus their new lower price of 4. So they lose $1 per unit for all of those 80 units, giving us a total burden, a total revenue loss of 80. Now, the calculation of the government revenue here, we can do this two ways. Always a good idea to do it both just to make sure we got it right. So it's the revenue per unit coming into the government. So that's the per unit tax times the number of units that are being bought and sold, i.e. the number of units that are being taxed. So T times QT will give us that revenue. But it's also going to be the sum of the consumer burden and the producer burden, right? So these values are how much, right, how much more the consumers are paying. That's how much they're contributing to the government. How much less the sellers get to keep in revenue, that's their contribution to the government revenue. So let's just double check this. So we have our $3 per unit tax. We've got 80 units being taxed. So 3 times 80, that should match consumer burden of 160 plus producer burden of 80. And it does, thank goodness. Both of them come out to 240. And we will also notice that the consumer burden of 160 is twice the producer burden of 80. That will be the follow-up question. But as far as the calculations, you can memorize the formulas, but it's also fairly intuitive, right? The burden to the consumer, how much more they're paying, the burden to the seller, how much less they're receiving. Okay. And then we were also asked to show that on the diagram, right? So it's going to be the area as indicated by that little formula. So the consumer burden, remember, is PC minus PE times QT, right? So it's going to be the rectangle here. The producer burden, the old price, 5 minus the new price of 4, so that distance here, times the number of units sold times QT. So the consumer burden will indicate as this little purple region, producer burden indicated by this light blue, and that upper larger rectangle is the consumer burden, the lower smaller rectangle is the producer burden. And again, if you know the formulas, you can find it on the diagram and vice versa. If you remember what it looks like on the diagram, that'll also help you do the calculation. And again, we see that consumer burden roughly twice the size of the producer burden. Now, the follow-up question. We need to relate the relative size of the burdens, the consumer versus the producer, to that elasticity of demand, right? To the relative elasticities on the two sides of the market. So obviously, the consumer burden is larger than the producer burden. What does that have to do with elasticity? So if we go back to the very beginning, right, and think about what happened when that tax was imposed, right, and we start at our original equilibrium here, the seller is experiencing this $3 increase in their cost of production. So they're going to be tempted to just say, well, I'm just going to raise my price by the full amount of that $3 up to this value here. But we note that as that price rises, consumers have some ability to fight back in the form of just not buying the product, right? The law of demand, as the price goes up, quantity demanded falls. With a relatively inelastic demand, like we're seeing here, that steep downward sloping demand curve, it means that change in quantity is going to be relatively small, and it's going to create a relatively small surplus here, which isn't going to take a whole lot of adjustment to dissipate. So the sellers attempt to pass the entire amount of the tax onto the consumer, but they have to backtrack a little bit to absorb that decrease in quantity demanded. But because of that steepness, that inelasticity, it didn't take much, right? So they almost were able to succeed in passing the entire burden onto the consumer. So the more elastic a demand curve is, the better able the consumer is to fight back against a tax in the only way they have, which is not buying the good that's being taxed, right? Uh, so in this case, the consumers don't have a great ability to do that. They have an inelastic demand, are unable to escape the tax burden to a large extent. So make sure that you can articulate that relationship between elasticity and tax burden. And again, circling back, that's why we wanted to make sure to draw the graph correctly, right? Because numerically, it was going to come out that the consumer burden is larger than the producer burden, and to show that graphically, we needed a relatively inelastic uh, demand curve. So a steep demand and a flat supply will give us the result here. Okay, one more issue here. Not only are consumers paying more and producers receiving less for the units that are still traded, but there's also a cost that comes along with the loss in the units traded. So as a result of the tax, we see that the quantity goes from 100 down to 80. Each of those 20 units that are no longer being consumed or sold had a consumer surplus and a producer surplus attached to it. Those are no longer occurring, so that surplus doesn't exist, and that's what's known as our deadweight loss, right? So when you're asked to explain a deadweight loss, it's that lost social welfare, that lost total surplus due to a movement away from equilibrium. In this case, as a result of the decrease in quantity due to the tax. So it's going to be this area, right? Some of it's coming from the consumers here. That used to be a part of consumer surplus area between the demand curve and the price, but there's no surplus happening because those units aren't being bought and sold. And likewise, producers had some degree of surplus revenue above cost for those units, and that is gone as well. So it's going to be this combination, this little triangle here, bounded by the two quantities and the supply and the demand curve at the top and the bottom. Okay. So again, make sure you can show that on a diagram and articulate what it represents. All right, there is our little example tax question. Hope that was helpful. See you next time.